Before we get into implementing abstraction within our repositories, I just wanted to quickly explain to you what abstraction was. Imagine we had two classes, dog and cat. They both have three identical properties and they both have an identical function that returns some calculation. Now normally we could then access each of these. Dog is man's best friend, legs, loyal, and again we can do the same with cat. However, because each of these contains all the same methods and functions, what would be great is if we could have a way of just combining them into a single class, and that's what abstraction is about. So instead of having public class dog, we'll have class animal, which will expose all those functions. If we take that out of there, and then what we can say is public class dog implements animal. So now what happens is, if we do the same to cat, up here, even though dog and cat don't actually implement anything of their own, we have access to all the properties and all the functionality underneath them. We can go one further and say public abstract class. Now what the abstract method does, it prevents us actually creating a class of animal on its own. In other words, it says you can only use that class if you implement it within another class. And one of the other benefits with this is that you can also then override methods. So if we add another method in here, is dog turn true. You can see that although dog now has the isDog method, cat does not. So that's the basics of abstraction, and by using this principle we're going to simplify our repository model. So what we can now do is implement this within a class called repository base. Now repository base also implements something called generics, which is basically just a way of allowing us to pass through an object and it will work out what to do with that object when it gets it. So as you can see here, we've got an abstract class, which means we can't use it on its own, we can only implement it. We're going to define some basic common settings. We've got a constructor there that just hooks things up, and then we've got our standard methods: get by ID, get all, insert, update, delete, plus a couple of other methods that we will use later on. What we can then do is if we take the customer repository, we can implement that repository. So repository base, we tell it we're going to be using a customer, and then the only other thing we need to do is we need to create a constructor, which is basically just a method that gets fired every time the class is instantiated. And this base keyword is a way of sending through something, in this case a data context, through to the underlying repository base class, because here we want to receive a data context. So because we're inheriting from it, we take a data context and pass it through to the class that we're implementing. And then we will just have a quick check if context is null. We need to just throw an exception, because this won't work unless we actually have a context. New argument section, that's better. Okay, so now just to show you how we will use that, again, if we go back to our web UI and go to our home controller, we can now create an customer repository. We send in a data context. And we can now access all our methods within the context for adding and updating fields accordingly. So now we're ready to go to start using all our repositories. All we need to do now is update the product repository to use the same methods. So I will just copy that into there. Get rid of all that. And again, we can now access each underlying products. Now we've done that, we're pretty much ready to go. Entity Framework will automatically create the database every time we start up the project, but actually we don't want to do that. What we need to do is control how Entity Framework manages and updates the database accordingly. And to do that, we're going to implement something called migrations, and I'll show you how to do that in the next lecture.